Hello everyone, my name is Arlindo Silva and I'm the Program Director for the Master of Engineering Innovation by Design from SUTD, and today I will be talking to you about innovation by design. This is a little bit about me. In the context of this presentation, I would just point out this part here of my resume. I have developed a number of patents with my students on innovative designs, which has everything to do with the topic of today's presentation. And my entire career has revolved around product design and development, which is also in line with what I'm going to talk to you about today. So I will be talking about design, innovation, creativity, design thinking. These are all buzzwords nowadays, and I would like to demystify a little bit of those words today. Some guidelines for design thinking, how can companies actually benefit from design, and I will present afterwards a new program in innovation by design. So for the buzzword, so what is design? Design is a word that everyone uses, but it has multiple meanings to multiple people. So design for us is the conception and planning of the artificial. The words are not ours, but it is a very good definition of what design is. And it can be developed around symbolic or visual communications, material objects, activities or services, and complex systems or environments. So it has no special application for each sector or each domain, but it's a more general way of thinking and mindset. Innovation is another buzzword, and everyone uses this word for all kinds of things. So for us, innovation is something that happens in the intersection of desirability, viability, and feasibility. That's what innovation is all about to us. So if you have a product that or system or service that users actually want, it's desirability. If from a business perspective it's a viable thing to do, then you have viability. And if it's technologically feasible, then you have feasibility. So that intersection there is what we call innovation. Creativity is another buzzword that is pervasively used to a lot of things, and I'm sure that you've come across diagrams like this that picture left brain and right brain, where left brain is more analytical, more mathematical, more abstract, whereas the right brain is more creative, more fun, more artistic, let's say. Our feeling is that creativity actually needs the two parts of the brain to come up with innovations that are interesting for the end user. So design thinking is another buzzword. Everyone talks about design thinking and applying design thinking. So design thinking is a methodology, but it is also a practice. So design is about doing things, and design thinking is about doing things that are human-centered. So they are centered around what people actually need or want. Who are design thinkers then in this context? I would say that we all are. We can always think like a designer. We may not have an education or a background as designers, but we can all be design thinkers in a way and have this design thinking mindset. So some guidelines for design thinking would be something that I'm going to dwell a little bit on, and you will realize that you can actually talk to designers and make sense of what you say to them and what they say to you if you follow these design thinking. So the very first one is a very simple one, is beginning at the beginning. And what I mean by this is that design is not just the cover or the outer shell of products or services. Design is how it works. As Steve Jobs used to say, design is how it works. And you need to involve designers right from the beginning of the innovation process. That's when you take out the most profit from involving designers. The other thing that you would have to bear in mind is that design is always a human-centered approach. So you need to be aware of user needs and context and behaviors and what their problems are. And this comes from direct observation to flesh out unexpected insights on what consumers want. So it's always a human-centered approach. You also need to try and fail eventually, early, and as often as possible, because you'll learn a lot more from failure than from success. And the problem with failure and success is that if you fail towards the right of this diagram, the costs of changing anything are quite substantial. Whereas if you fail at the concept stage and you improve your designs or your ideas right at the concept stage, the costs incurred are much, much lower, and hence you have much, much more benefit from failing early than from failing late. So rapid experimentation and prototyping are crucial, and early failures are much cheaper than later failures. Prototyping, therefore, is connected to prototyping from an early stage. But you need to prototype wisely. Just don't do stuff because it's fun to do stuff or because you have to do stuff. Prototyping is for learning, and prototyping should have the appropriate effort at the appropriate phase of the design process or the innovation process. So what you see here, for instance, is a prototype of screens for a service that is to be conveyed by a handphone or a smartphone. Okay, and then you typically look at prototypes or think about prototypes as something very close to the real product, but they do not necessarily have to be like that. This is an early prototype of a product that you might know. Uh, it's a cardboard prototype. It obviously doesn't work absolutely as intended, but it gives you a lot of ideas on how the Wii game console can actually work. And how does it tell you a lot about that? Because you see ergonomics here at play. The fingers need to reach the buttons, and the flow of information in the screen needs to be coherent with what you select with the buttons. So from an ergonomics point of view, this prototype at an early stage can tell you quite a lot about this product. No single person knows everything there is to know about a particular system or a particular product or service. So seeking outside help is more often than not very, very important and absolutely necessary for the design team. So having an ecosystem of users, but also of co-designers and uh, consumers is extremely important as you develop your products. Tap on their knowledge at all times and get their feedback and get their knowledge into your product as much as possible and as often as possible. Blending big and small projects is also very important because sometimes we embark in very big projects and you don't see the light at the end of the tunnel. So having big and small projects working concurrently actually gives you this added benefit of finishing something. So having short-term projects but also long-term projects, potentially revolutionary projects that are going to bear fruit somewhere down the line. Be clear and thorough about what it is that your changes to the project or the product or the system can influence or not other parts of the system or the ecosystem. So if you know exactly where your changes affect other parts of the system, it is extremely important. Why? Because when it comes to trade-off analysis, you will know which things have more importance to your project and to adjacent projects or products in your company. Being a co-designer is extremely important because, as I've said previously, designing is typically a team endeavor. And being a team endeavor, if you co-design with your team but also with your end users, it becomes a much more fun process and a much more enriching process for both you and your potential customers downstream. So if you consider that you're designing with your end users instead of for them, it is actually a much better approach to design. Being an informed designer is also extremely important. And you can see here on your right an image of a smartphone. It has no brand, it has no particular features that identifies what it is, but you immediately look at it and you see that it's a smartphone. So being an informed designer entails knowing what's behind this as well. And most importantly as well, or perhaps most importantly, is the history behind how did this come to be the way it is right now. So think of phones, think of making calls, think of the first phone. When was the first phone made available to the public? I'll give you a few seconds to think, but I'll tell you immediately what the answer is. The first phone was made available in 1876 by Alexander Graham Bell. That was the phone inventor. In fact, it was invented almost at the same time by two completely separate people, but that's another story. We're not going into that right now. So this phone on your left is completely different from this phone on your right. And the one on your right is what we could call a cell phone or a wireless communication. It relies on wireless communication. So from the phone on your left to the phone on your right, there was a lot of evolution. But for specifically cell phones, do you actually know when they were made available to the public? And again, I'll give you a few seconds to think about that, but I will show you right away. So in terms of cell phones, their history stems from the late 70s, perhaps, of the last century. And you see here an example of how they've evolved through time. This is one of the first cell phones that were made available to the public. By the way, these are all the same brand. And you see an evolution of the features. And they are not monotonous, this evolution. It changes over time, right? So, for instance, one immediate feature that you can look at is the size of the screen. And here on the left, it is very, very small, and then it increases towards your right. And in here, it's a big screen. It almost occupies the entire interface of the cell phone, right? In here, you also see a lot of keys, and they evolve to zero, or virtually zero keys. Actually, you can only see one in here. There are other keys, but you can only see one at the front. The size is a very interesting thing as well, looking from the outside, looking just for the external shell of the thing. So this is very, very big, and it decreases in size, but up to a certain point only, and then it starts increasing again. And you would wonder, why is this so? Some things increase monotonically, some things decrease monotonically, some things have an inflection point. What's happening in this evolution? So I would say that there are two conflicting evolutions here. One is the number of services that this product provides. In here, it provides one service, which is making calls. In here, it provides a lot more services besides making calls. It actually is very, very infrequently used for making calls anyway. And for that, you need a lot of power and a lot of real estate in terms of interface, right? You need to see a lot of stuff. Whereas in here, you probably just see a number. It's the number that you're calling, right? So, but with a lot of services comes also a lot of energy required. So, which that brings us back to something very, very hidden behind the overall way that you look at the phone, that's battery technology. In here, most of the volume is taken up by the battery itself. Whereas here, the battery, although big, it doesn't take up most of the space. Most of the space is occupied by other stuff. However, what made this possible was the evolution of battery technology from the 1970s up to this point in time. Another example of informed design could be this one. Let's look at mobility. And you have here a Tesla Roadster. It's an electric car, and we know that electric mobility has been gaining importance in recent years. So it almost begs the question, so when did electric mobility actually was first made available to the public? When was the first electric car made available? Again, I'll give you a few seconds to think about this, but I will tell you in my next slide, which is this one. So in fact, the first electric car was made available in 1904. It's a German electric car. And you can see actually here a very interesting thing. This car is very, very similar to that other car in the background that is clearly not moved by electricity. So this is also an important thing to note. When technologies are evolving, there's a lot of competing technologies at the same time. In the beginning of the 20th century, you could have gasoline-powered cars, electric-powered cars, or steam-powered cars. And the gasoline-powered car became the dominant design because it was the one that evolved faster and gave more advantages to their users. Now, with the evolution of battery technology, that seems to not be the case anymore. So now we're getting to see a revival of electric mobility as well. So how can companies benefit from this whole approach of design thinking? There have been several studies from different organizations looking at the impact of design in companies and how design is used throughout the organization. For instance, McKinsey has done a study that shows that when companies adopt a design mindset, they actually benefit a lot more than other companies that do not use design thinking pervasively throughout the organization. So there are advantages at getting this mindset across the entire organization actually. In Singapore, in the Singapore context in particular, Singapore Design Council has also done a study related to design and how design can affect companies' profits. And it's very interesting to understand that, for instance, right now, around 20% of our workforce, which is more or less 750,000 jobs, is actually related to design. And we may not have this idea that design is already so much ingrained in our workforce, but it is true. Design is there. And the study has shown that again, uh, and again in line with the overall study that McKinsey did and others did as well, in Singapore there's a lot of advantage to use design throughout your organization. So the AAA is the way in which you use design. If design is in your mindset across the entire organization, there is a 10% difference in average profit margin as compared to companies that do not use this design mindset. Conclusion of this study from Design Singapore was a master plan for 2025 that looks at how we could develop design mindset at a national level. Of course, this applies to international as well, but For the particular case of Singapore, this master plan would look at infusing design into our national skill set, expanding the role of design in business and government, strengthening the competitiveness of design firms, and bringing design into the community and developing a Singapore design brand. And this naturally brings us back to our Masters of Engineering in Innovation by Design and how we wrap this whole thing around a master's program that fosters innovation with a design mindset. And that's exactly what we try to do with this program at SUTD. I am going to now tell you a little bit more about this program and how this program caters to all of these factors that we've been talking about during this presentation. This program relies on innovation by design, as we've seen previously, desirability, feasibility, and viability, and these are the things that we dwell right from the start of the course on a module that's actually called Innovation by Design. And these are the basic elements of our Innovation by Design program, or IBD for short. It is based on deep research embedded in research centers for all our students, development of leadership skills, also based on a unique design pedagogy that we have particularly developed at SUTD, and also 3 accelerators and experiences that happen at different points in time during our program. So a little bit more on IBD from now on. The opportunities that we give to students on various research centers are scattered throughout our knowledge base at SUTD. So the iTrust, the Center for Research in Cybersecurity, has taken in some of our students from the first batch. But also Temasek Labs and the Lee Kuan Yew Center for Innovative Cities, the Game Lab, the Digital Manufacturing and Design Center, and the International Design Center. So we've all distributed our students throughout our research centers to give them a broad overview of what it is that design can be applied to. Our program, for those that are Singaporean, starts with a red dot. Our first term core course is Innovation by Design, and our second term core course is Design Science. In all terms, we have a number of elective courses that students can opt to take or not, and you will see I will not go through all of the electives, but you will see that there's a very diverse set of electives that caters for mostly all of the research topics that students are interested in pursuing. Term 2 electives, you can see them right here, and Term 3 is only elective courses. There is no compulsory course. So throughout the year, you will have an ideate, prototype, realize thread that is basically an individual project that eventually will lead to a student thesis in the end. There are the accelerators, the Entrepreneurship Accelerator, Design Accelerated, and Overseas Experience. These are things that can take from 3 days to 1 entire week. Some are done at SUTD, some are done overseas in collaboration with other institutions. More on that a little bit later. And eventually this leads to a thesis, an individual thesis for all of the students in this master program. Our target audience for this is very diverse. We are targeting fresh graduates with an engineering background, but also other backgrounds, because we feel that design is not exclusive to an engineering background, but it's also done by other individuals as well. We are also targeting design professionals that want to incorporate systems thinking and new innovation methods in the way they do things, and mid-level engineering professionals who want to improve their skill sets. And this does not have very identifiable faces. This is just a kind of a general thing. Our first batch of students, it's here. And you see just from their faces that the level of experience and the number of years of experience is very broad. We have fresh graduates together with people with a lot of experience from industry, engineers, material science, biologists, IT people, business people, managing people. We've all gathered them in this master program for our first batch in 2019. The first intake in September last year was very diverse. I am not going to read all of that, but you can see the diversity of people that we brought in our cohort. And this diversity enriches learning and design practice. And you will understand coming into this program that if you have a diverse team to work with, you'll have a lot of perspectives that you will take into account as you develop your products and as you develop your systems and your services. So far, from September 2019 up to now, we've done a number of elements of this Masters of Engineering. We've gone through our Innovation by Design course, we've gone through our Design Science course, our Design Accelerator, which is specifically catered to those that have less background in design, and we've gone through our overseas experience. In particular, our overseas experience is what these photos are all about, and it was a one-week design sprint at the School of Design of the Jiangnan University, where we put our students, our 30 students, together with 20 students from Jiangnan University, and during 1 week they've come up with 10 prototypes, and they've done 2 company visits. Those 10 prototypes were their response in 1 week to a design brief that we gave to all of these students working in the mixed teams. So far in Ideate, Prototype, Realize, the students are going through their projects, and what you see now appearing on the screen are the topics that the students are doing their research on. You will see that it is extremely broad, and it goes from, for instance, chitosan-based organic and inorganic composites, all the way to urban metabolism in Singapore, or turbulent flow with machine intelligence, or integrated living communities. And this is made possible because the students are embedded in our very diverse research centers, and they have been paired up with advisors that can actually scaffold their learning on these very diverse topics. So I'm reaching the end of my presentation, and this is what we uncovered today: design, innovation, creativity, design thinking. What's it all about? Why are these buzzwords? What's behind these words? Design thinking guidelines for those that are interested in pursuing this kind of education. How companies benefit from design, what's in it for them. And I also presented the new program in Innovation by Design, or IBD as we call it. I would say that so far we've been successful. We only have 1 batch of students, but the feedback that they gave us is that they're learning a lot throughout this process, and they're very interested and motivated to continue doing work in this area. So concluding all of this presentation, thank you all for being available to look at our video. And if you have any questions for us, just get in touch. Use this email right here on the bottom right, and we'll be happy to talk to you and provide more information if needed on this program. And I am personally looking forward to hearing from you on this. Thank you, and bye.